Hello everybody, getting ready to do lesson 1.3 part 2 of Algebra 2 Math. And today's lesson is about solving ax squared plus bx plus c by factoring. We got a 28-point skill sheet for classwork today, and then we have a 10-point notebook guide for this lesson. And no bell work today, so we go right into our lesson. Factoring special products, quadratic expressions, often involves trial and error. However, some expressions are easy to factor because they follow special patterns. So, special factoring patterns here for this table, we're going to fill in patterns of difference of two squares. The pattern is here. A squared minus b squared, you have a plus b, a minus b. And then this will be an example of that. And then perfect square trinomial would be this situation here, a plus b squared. And the situation would be here, x plus 3 squared for this trinomial here. And then a squared minus 2ab plus b squared. This will be a difference of a perfect square trinomial, a minus b, b squared, excuse me. And then this will be an example of that. Okay, so we have our special patterns here, special patterns there. And then we go into our first example here, example 2 of this section. Factor with special patterns, factor the expression. So we have a situation here, x squared minus 49 is the difference of two squares here. So x squared minus 49 is the same thing as the x squared minus 7 squared. So we follow our pattern. X plus 7, x minus 7. And then factor this expression here, d squared plus 12d plus 36. So that would be a perfect square trinomial here. D squared plus 2d 6 plus 6 squared would be the pattern here for this one. So it would be d plus 6 squared would be the situation here for this one, d plus 6 squared. And then we go into another situation here, factor this expression, z squared minus 26z plus 169. So we have a situation here, we have a perfect square trinomial, but this time it's a difference. We have a negative sign here in front of our AB member there. So it'll be z minus 13 squared. Okay, let's see if we can factor x squared minus 9 now. Students, this is yours here, so pay attention. This is, watch. Okay, x squared minus 9, we have x squared minus 9, same thing with as x squared minus 3 squared. We have a difference of two squares. So it would be x plus 3, x minus 3 is our pattern here for a difference of two squares. You can use factoring to solve certain quadratic equations. A quadratic equation in one variable can be written in the form ax squared plus bx plus c, where a does not equal 0. This is called standard form of the equation. The solutions of a quadratic equation are called the roots of the equation. If the left side of this can be factored, then the equation can be solved using the zero product property. So, students, in your own words, define quadratic equation and define roots. In your own words, students, this is 10 points. Notebook, page 6. I'll be checking your notebook on that. Okay, zero product property. Words, if the product of two expressions is 0, then one or both of the expressions equals 0. So for the algebra, if a and b are expressions and ab equals 0, then a equals 0 or b equals 0. Example, so we have x plus 5, x plus 2 equals 0, then x plus 5 equals 0, x plus 2 equals 0. That is, x equals negative 5 or x equals negative 2. So we know that much there to get a 0 as a product of these two factors here. So let's try this out. What are the roots of the equation x squared minus 5x minus 36? So we have multiple choice here. First, let's factor it so we can find out what our roots are. X minus 9, x plus 4 is what this factors out as. We know that, we can find our roots. So x minus 9 equals 0, or x plus 4 equals 0. So in this case, x would equal 9 or x would equal negative 4. Those would be your positive roots, so the answer would be C for the multiple choice. So into our next guided practice here, number 5. Students, this is yours here. Use this table to factor. Solve the equation x squared minus x minus 42. Students, this is yours here. Use your table here to factor that trinomial. So x squared minus x minus 42, what are the possible factors? Well, negative 7 times 6 would be negative 42, then negative 7 and 6 would be negative 1, so that's how we get this factoring here for this trinomial. So by using our zero product property, x minus 7 equals 0 or x plus equals 0, so we get two solutions there, and that is less than 1.3. Part 2. And part 3 would be available here at this email, as well as worksheets and tests and the quizzes for this area of Algebra 2, as well as the class worksheet and the homework sheet. Thank you.